Computer engineering is a fascinating field that combines two major areas of study: computer science and electrical engineering. Think of it as the place where ideas about software meet the physical reality of hardware. Computer engineers are the architects and builders of the digital world we live in. They design and create the tiny, powerful components that make our computers, smartphones, and countless other devices work. This field is all about making technology smaller, faster, and more powerful. It involves understanding how electricity can be used to process information, and then using that knowledge to build useful and innovative products that change how we live, work, and play. So, what does that really mean? It means computer engineers work with both the brain and the body of a computer. The brain is the software, the set of instructions that tells the computer what to do. This includes operating systems like Windows or Mac OS, and the applications we use every day like web browsers or games. The body is the hardware, the physical parts you can touch like the processor chip, the memory sticks, and the motherboard that connects everything. A computer engineer needs to understand both sides of this coin to create a complete functioning system. They are the bridge that ensures the software's commands are perfectly executed by the hardware's circuits. This blend of skills makes computer engineering a very versatile and powerful discipline. Unlike a pure software developer who might focus only on code, or a pure electrical engineer who might focus only on circuits, a computer engineer understands the entire system from top to bottom. They can design a new microprocessor, and then write the low-level code that makes it run efficiently. This holistic view is crucial for pushing the boundaries of technology. They are problem solvers at heart, constantly looking for better ways to make electronics communicate, process data, and perform complex tasks with incredible speed and accuracy. Imagine building a robot. A computer engineer would be involved in designing its electronic brain, the central processing unit that makes decisions. They would also help design the sensors that allow the robot to see and hear, and the motors that allow it to move. Then, they would write the fundamental software that connects all these parts, allowing the robot to interact with its environment. This complete approach, from the smallest transistor to the most complex algorithm, is the very essence of computer engineering. It's about building the intelligent systems that define our modern era and shape the future of technology for everyone. The work of a computer engineer is incredibly diverse, covering a wide range of tasks and responsibilities. At their core, computer engineers design, develop, test, and oversee the manufacturing of computer hardware and software systems. They are the masterminds behind the microprocessors that act as the brains of our devices. They also design the circuit boards that hold all the components together, ensuring that every part can communicate with every other part seamlessly. This involves detailed planning, creating blueprints using specialized software, and simulating how the components will work together before a single physical part is ever made. Their goal is to create efficient, reliable, and powerful electronic systems. On a typical day, a computer engineer might be found in a lab testing a new prototype of a circuit board. They might be soldering tiny components by hand or using sophisticated equipment to measure electrical signals. Alternatively, they could be in an office, writing firmware. Firmware is a special type of software that is embedded directly into a piece of hardware, giving it its basic instructions for how to operate. For example, the firmware in your television is what allows it to turn on, change channels, and connect to the internet. This requires a deep understanding of how the hardware works at its most fundamental level, a skill that is unique to this field. Collaboration is a huge part of a computer engineer's job. They rarely work in isolation. Instead, they are often part of a larger team that includes software developers, electrical engineers, project managers, and designers. A computer engineer acts as the critical link between these different experts. They might need to explain the limitations of a certain type of memory to a software developer, or work with an electrical engineer to solve a power consumption issue on a new chip. This requires strong communication skills and the ability to translate complex technical concepts into terms that people from different backgrounds can easily understand and work with. Beyond designing new products, computer engineers also play a crucial role in improving existing technology. They might be tasked with making a smartphone's battery last longer, increasing the processing speed of a laptop, or making a wireless network more secure. This involves a continuous cycle of research, development, and testing. They analyze current systems to find bottlenecks or inefficiencies, and then devise clever solutions to overcome them. In this way, computer engineers are not just inventors, they are also refiners. constantly polishing and perfecting the technology that underpins our modern society, making it better, faster, and more accessible for all of us. Every computer, from the giant supercomputers used for scientific research to the tiny one inside your smartwatch, is built from a few essential components working in harmony. The most important of these is the Central Processing Unit, or CPU. The CPU is often called the brain of the computer, and for good reason. It is responsible for executing instructions and performing calculations. Every time you click your mouse, type a key, or open an application, it is the CPU that processes that command and makes it happen. It reads instructions from the computer's memory, performs the required operations, and then sends the results back. The speed of the CPU, measured in gigahertz, determines how many instructions it can carry out per second. Next we have memory, which is also known as RAM, or random access memory. RAM is the computer's short-term workspace. When you open a program or a file, it gets loaded from the long-term storage into the RAM. The CPU can access data from RAM very quickly, which is why it's used for active tasks. Think of RAM as the top of your desk, where you keep the papers you are currently working on. The more RAM a computer has, the more tasks it can handle at the same time without slowing down. However, RAM is volatile, which means that when you turn off the computer, everything stored in the RAM is erased. For long-term data keeping, computers use storage. Unlike RAM, storage is non-volatile, meaning it holds onto your data even when the power is off. This is where your operating system, your applications, your photos, and your documents are permanently saved. There are two main types of storage: hard disk drives and solid-state drives. Hard disk drives use spinning magnetic platters to store data, kind of like a tiny record player. Solid-state drives use flash memory chips, which have no moving parts, making them much faster, more durable, and quieter. This is the filing cabinet where you store all your important information for later use. Finally, we have the input and output devices. These are the parts of the computer that allow you to interact with it and allow the computer to communicate back to you. Input devices send information into the computer. Examples include your keyboard, mouse, microphone, and webcam. Output devices receive information from the computer and present it to you. The most common output devices are your monitor, which displays images and text, your speakers, which produce sound, and your printer, which creates physical copies of documents. All these components are connected through the motherboard, a large circuit board that acts as the central nervous system, allowing every part to talk to each other. To succeed as a computer engineer, one needs a strong foundation in both technical knowledge and practical abilities. First and foremost, a deep understanding of mathematics and science is essential. Calculus, physics, and discrete mathematics form the bedrock of engineering principles. These subjects teach you how to think logically, analyze complex systems, and solve problems in a structured way. For example, physics helps you understand how electricity flows through circuits, while calculus is used to model and analyze the behavior of electronic signals. Without this fundamental knowledge, designing efficient and reliable hardware would be nearly impossible. Beyond the theoretical, computer engineers must be proficient in several programming languages. While software developers might specialize in high-level languages like Python or Java, computer engineers often work closer to the hardware. This means they need to be skilled in languages like C and C++, which offer fine-grained control over system resources like memory. They also frequently use even lower-level languages like assembly, which communicates almost directly with the CPU. Expertise in hardware description languages such as VHDL or Verilog is also crucial. These are used to design and model the behavior of digital circuits before they are physically built. Problem solving is perhaps the most critical skill in a computer engineer's toolkit. Technology is complex, and things rarely work perfectly on the first try. A computer engineer must be a master detective, able to diagnose problems, isolate the cause, and develop an effective solution. This requires a patient and methodical approach, often involving hours of testing, debugging code, and analyzing data from electronic test equipment like oscilloscopes and logic analyzers. Creativity is also surprisingly important. The best engineers don't just fix problems, they find innovative and elegant solutions that can lead to breakthroughs in performance or efficiency. Finally, soft skills are just as important as technical ones. Computer engineers almost always work in teams, so the ability to communicate clearly and collaborate effectively is vital. They need to be able to explain their ideas to other engineers, project managers, and even clients who may not have a technical background. They must also be able to listen to feedback, manage their time effectively to meet deadlines, and adapt to new technologies and challenges. The world of computing is constantly evolving, so a commitment to lifelong learning is a non-negotiable part of the job. The drive to stay curious and keep learning is what separates a good engineer from a great one. The career paths for a computer engineer are, honestly, vast and pretty exciting, touching nearly every industry you can imagine. One of the most common roles is that of a hardware engineer. These professionals design the physical components of computers and electronic devices. They might work for companies like Intel or AMD, designing the next generation of CPUs and GPUs that will power future laptops and gaming consoles. Or, they could also work at Apple or Samsung, creating the custom chips that make smartphones smaller and more powerful. This job involves using sophisticated computer-aided design software, CAD, to create these really intricate circuit layouts and running extensive simulations to make sure the designs are flawless before manufacturing. Another popular path is becoming a firmware engineer. This role, honestly, perfectly blends hardware and software. Firmware engineers write the low-level code that lives directly on a piece of hardware, controlling its basic functions. For example, the firmware in a digital camera controls how it processes images from the sensor, adjusts focus, and saves files to the memory card. They also work on devices in the Internet of Things, like smart thermostats, security cameras, and connected home appliances. This is a critical role because, without well-written firmware, even the most advanced hardware is just a useless piece of silicon and plastic. Many computer engineers also find fulfilling careers in the field of embedded systems engineering. Embedded systems are specialized computers that are designed to perform a specific task within a larger system. Your car, for instance, contains dozens of embedded systems that control everything from the engine and anti-lock brakes to the infotainment system and airbags. An embedded systems engineer designs both the hardware and software for these systems, making sure they are reliable, safe, and efficient. They might work in the automotive, aerospace, medical, or consumer electronics industries, creating the invisible intelligence that makes modern technology work so seamlessly. Furthermore, some computer engineers specialize in areas like network engineering or cybersecurity. A network hardware engineer designs the routers, switches, and other physical equipment that form the backbone of the internet and corporate networks. They focus on creating hardware that can transmit data at incredible speeds with minimal delay. A cybersecurity engineer specializing in hardware security works to protect systems from physical attacks. They design secure processors and memory systems that can resist tampering and protect sensitive data from being stolen, a role that's becoming increasingly important in our interconnected world, where digital security is a top priority for everyone. It's really easy to overlook the profound impact of computer engineering because so much of its work is hidden from view, tucked away inside the devices we use every single day. But from the moment you wake up to the moment you go to sleep, computer engineering is quietly and constantly at work. The alarm clock that wakes you up, whether it's a dedicated device or just an app on your smartphone, runs on a microcontroller designed by computer engineers. The smartphone itself is honestly a marvel of computer engineering, packing a powerful processor, memory, storage, and a bunch of sensors into a slim and portable package. Consider your morning routine for a second. The coffee maker with a programmable timer, the microwave that heats your breakfast, and the smart refrigerator that might tell you you're out of milk, all of these contain embedded systems. These are small, dedicated computers designed by computer engineers to perform their specific functions reliably and efficiently. When you get in your car to drive to work or school, you are surrounded by their work. The Engine Control Unit, or ECU, optimizes fuel efficiency and performance. The GPS navigation system calculates the best route in real time, and the Advanced Driver Assistance Systems, also known as ADAS, use cameras and sensors to help keep you safe on the road. At work or school, the influence is even more obvious. The computers we use for writing reports, creating presentations, and communicating with colleagues are direct products of this field. But it actually goes deeper than that. The office building's climate control system, the security card scanner that lets you in the door, and the high-speed internet network that connects everyone are all managed by systems designed and built by computer engineers. In the world of medicine, their work is honestly life-saving. MRI machines, patient monitors, robotic surgical assistants, and pacemakers all rely on complex computer hardware and software to function, giving doctors powerful tools to diagnose and treat illnesses. Even our leisure and entertainment are shaped by computer engineering. The video game consoles that provide immersive digital worlds are powered by custom-designed processors and graphics cards. The streaming services that deliver movies and music to our screens rely on vast networks of servers and sophisticated data compression techniques, all of which fall under the umbrella of computer engineering. The digital cameras that capture our precious memories and the smart TVs that display them are also packed with advanced processing chips. In essence, computer engineering forms the invisible infrastructure of modern life, making our world more connected, efficient, and entertaining. For any student considering a future in computer engineering, the journey begins with a strong passion for technology and a curiosity for how things work. If you find yourself taking apart old electronics just to see what's inside, or if you enjoy solving complex puzzles, you already have the mindset of an engineer. The first practical step is to focus on your high school coursework. Excel in mathematics, especially algebra, trigonometry, and calculus, as these are the languages of engineering. Pay close attention in physics class because understanding electricity, magnetism, and mechanics is fundamental. Also, take any computer science or programming classes your school offers to get a head start on coding. Once you have a solid academic foundation, it's time to start building things. Theory is important, but computer engineering is a hands-on discipline. Start with simple projects using platforms like the Arduino or Raspberry Pi. These are small, inexpensive computers that are perfect for beginners. You can learn to write simple code to blink an LED, then move on to reading data from sensors, controlling motors, and building small robots or home automation gadgets. There is a huge online community with countless tutorials and project ideas. This practical experience is honestly invaluable. It will teach you problem-solving skills and look fantastic on college applications and future resumes. As you explore, try to get a feel for the different specializations within computer engineering. Do you enjoy designing circuits and working with hardware? Or do you prefer writing low-level code that interacts directly with the hardware? Maybe you're interested in the intersection of the two in embedded systems. You can learn more by reading books, following tech blogs, and watching videos from engineers online. Don't be afraid to reach out to people in the field. You can often find engineers on professional networking sites like LinkedIn who are happy to share their experiences and offer advice to an aspiring student who shows genuine interest and initiative. Finally, when it comes to higher education, look for university programs that have strong, well-funded engineering departments. A good program will have excellent lab facilities where you can gain hands-on experience with industry-standard tools and equipment. It will also offer opportunities for internships, co-op programs, or research projects. These experiences are crucial for applying what you learn in the classroom to real-world problems and for building a professional network. Remember that computer engineering is a challenging field, but it's also incredibly rewarding. Stay curious, keep learning, and don't be discouraged by setbacks. Every challenge is a learning opportunity on your path to becoming an innovator. The field of computer engineering is not static. It's actually one of the most dynamic and rapidly evolving disciplines in the world. The future promises even more exciting and transformative developments. One of the biggest areas of growth is in artificial intelligence and machine learning. As AI algorithms become more complex, they require specialized hardware to run efficiently. Computer engineers are at the forefront of designing AI accelerator chips and neuromorphic processors that mimic the structure of the human brain. These custom-built chips will power the next generation of AI in everything from self-driving cars to medical diagnostics, making AI faster, more powerful, and more energy efficient. Another major frontier is the Internet of Things, or IoT. The vision of a world where every device is connected to the internet is quickly becoming a reality. Computer engineers are tasked with designing the billions of tiny low-power microcontrollers and sensors that will be embedded in our homes, cities, and industries. They face the challenge of making these devices not only small and cheap, but also highly secure. Ensuring the privacy and safety of data collected by a vast network of IoT devices is one of the most critical tasks for the next generation of engineers. This will require innovative solutions in both hardware and firmware design. Quantum computing represents a paradigm shift in processing power, and computer engineers are playing a vital role in turning this theoretical concept into a practical reality. While physicists work on the fundamental principles of quantum mechanics, computer engineers are designing the incredibly complex hardware needed to build and control quantum bits, or qubits. They're developing the cryogenic cooling systems, the precise microwave control electronics, and the error correction systems that are essential for a stable quantum computer. While still in its early days, quantum computing has the potential to solve problems that are currently impossible for even the most powerful supercomputers. Finally, the push for sustainable and green computing is shaping the future of the field. As our reliance on technology grows, so does the energy consumption of data centers and electronic devices. Computer engineers are working hard to design more energy-efficient processors, memory, and networking equipment. This involves creating new low-power circuit designs, developing smarter power management techniques, and exploring new materials. The goal is to continue the march of technological progress while minimizing our impact on the environment. The future of computer engineering is not just about making things faster and smaller, it's about making them smarter, more secure, and more sustainable for everyone. We have journeyed through the world of computer engineering, from its basic definition to its exciting future. We've seen that it is a rich and rewarding field that sits at the crossroads of hardware and software. Computer engineers are the essential architects of our digital age, designing everything from the microscopic processors in our phones to the massive systems that power the internet. They are the problem solvers and innovators who build the tools, toys, and technologies that have fundamentally reshaped our world. The work they do is often invisible, but its impact is felt in nearly every aspect of our modern lives. Understanding the core components of a computer, the CPU, memory, storage, and I/O devices, is the first step to appreciating the complexity and elegance of these machines. We have also seen that success in this field requires a unique blend of skills. Strong technical knowledge in math, science, and programming must be combined with practical problem-solving abilities, creativity, and the collaborative spirit needed to work in a team. The career paths are as varied as the technology itself, offering opportunities in hardware design, firmware development, embedded systems, networking, and so much more. There is a place for every kind of curious mind. For students with a spark of interest, the path forward is clear. Build a strong academic foundation, get your hands dirty with personal projects using platforms like Arduino or Raspberry Pi, and never stop asking, how does that work? The world needs more creative and dedicated computer engineers to solve the next generation of challenges. Whether it's building the hardware for artificial intelligence, securing the Internet of Things, pioneering quantum computers, or creating more sustainable technology, the opportunities to make a meaningful impact are honestly limitless. The field is constantly changing, which means there will always be something new to learn and create. This guide has provided a map, but the journey is yours to take. The adventure of computer engineering is one of continuous discovery. It is a field for those who love to build, to solve, and to imagine a better future. If you are excited by the idea of shaping the technology of tomorrow, then you are already on the right track. Embrace your curiosity, tackle the challenges with persistence, and you can become one of the engineers who builds the next amazing thing that changes the world. Your journey into the fascinating and vital world of computer engineering begins right now.